Interesting is right here, using a cipher query in R, we can do the exact same thing. So Japan and OB is a data field in which I'm going to store the exact same query and the exact same output. So what we can do is we can run the same thing, and we find, if we look here to the output, that Japan and OB should be equal to the exact same thing, and it is 502. That's beautiful. So an interesting thing about Cypher is that when we return something in the Cypher query, it actually returns data of that particular type. It returns it in a data frame, which is great for R. Data frames are very variable, and they allow for great analysis. So what I did was I can keep going through this analysis of the disease landscape in Japan. And so what I did was I said, I found 502 outbreaks. That's a whole lot of outbreaks. I wanted to see if there's any particular temporal trend. Are we seeing more outbreaks as time goes forward towards the modern day, or were there more outbreaks in the 1980s and now Japan is on the whole healthier? And so I ran what I did was I said, this time what we're going to do is match to the country and the outbreak. We're going to do the same thing. Where C country equals Japan. But this time, instead of just returning the counts of the number of all outbreaks, what I want to do is I want to return the year in which the outbreak occurred, and I want to say exactly how many outbreaks occurred in that particular year. And so this is going to spit out a table. This is unordered, but it's great. It's a breakdown of the number of outbreaks that have occurred in Japan for each year. So I can do the exact same thing as I have here in Japan time series, and we see the exact same output. So what I've done is I've ordered it by year right here, and then I plotted it. I wanted to see if there was an obvious temporal trend. So it looks like there is. I know these are very light, but it's to accommodate for something later. And it looks like in the 1980s there weren't too many outbreaks that were reported or occurring in Japan, and now in particular around 2000 there's this really big spike. So I wanted to see if there was a real relation between the two of them. So I ran a linear model, which is a regression. I created a regression line, and that's in Japan LM, which showed a significantly, so p is equal to 0.01, trend, upwards temporal trend. So that's to say that there are significantly more outbreaks that are occurring now than there were in the 1980s. So we can add that line to the graph, in addition to pasting the text, the p-value, onto that graph. And so that demonstrates, that's a good demonstration of the functionality of the R-Neo4j in integrating the power of the Neo4j database and querying and storing the data, in addition to pipelining that data directly into an R analysis. So it was just a basic linear model, but even so, that's a large amount of functionality. So the second part of the analysis for Japan was, back to these 502 outbreaks. That's a lot of outbreaks. So are there outbreaks that are particularly common, outbreaks of a particular type of disease, one versus another, and how does that compare to the rest of the world? So I ran this query, which is the disease count, where instead of specifying instead of counting the number of outbreaks by their year of occurrence, what we did was I counted them by their disease. And so we could run that, and we find Japan disease count. And we get a whole list of all of the diseases that have incurred outbreaks in Japan. And the top is Escherichia coli diarrhea. That's E. coli. That's an E. coli outbreak. And so that's a lot of outbreaks of E. coli, actually, which is really interesting because, a really typical transmission of E. coli actually happens when one eats raw fish. And that is AKA sushi, perhaps. So I wonder if a population-wide greater eating of sushi leads to a lot of E. coli diarrhea. But on the other hand, maybe this is just, across the world we see a lot of E. coli. So what I did was I created a bit of a bar plot to visualize this. In addition to, I wanted to run an enrichment analysis. So that's to say, is the risk of incurring an E. coli outbreak in Japan significantly higher than we expect based on the number of outbreaks of E. coli in Japan, the number of outbreaks of non-E. coli in Japan, and then the number of outbreaks of E. coli in everywhere else other than Japan, and the number of other outbreaks all in every other country in the world. So effectively, I'm creating a contingency table. That's what they're called, and I'm running a Fisher exact test. So I'm not going to rerun the query, but I will rerun the Fisher exact test right here, and you can look at the code. And I was interested in a higher than expected risk of E. coli outbreaks, so I ran a right-sided Fisher exact test. We can run this right now, and we see right here that the p-value is really, really, really low. So that's to say that in Japan, one has a significantly higher risk of having an E. coli outbreak than is expected based on the number of E. coli outbreaks in the rest of the world. Great. Thank you so much, and if you have any questions, please feel free to contact me by email. And that concludes my demonstration of my code for the day. Thanks so much and have a good one.